In last class, we have seen electric poles and steel towers. The other side of these supports, there may be a substation to serve as a sending and receiving the power to the users. In this class, we are going to learn what are the different components present in substation, and in electrical drawing point of view, just basic things, how to connect these components in a sequential order to protect our electrical systems. Dear students, you can see this is one of the practical 230 kV substations. As we know that in India, in AC power transmission from 132 kV, 220 kV, 400 kV and 765 kV is the maximum transmission in our India. Coming to the DC side, our maximum voltage plus or minus 500 kV, and also some places implemented plus or minus 800 kV circuits. As electrical students, we should learn what are the different components present in electrical substations, how we are going to operate those equipments. So, first of all, what do you mean by substation? A substation is a part of an electrical generation, transmission and distribution system. Substation transform voltage from high to low or the reverse, or perform any several other important functions. Based on these functions, we are also classifying these substations. Let us see later with diagrams. Now, between the generating station and the consumer like us, electric power may flow through several substations at different voltage levels. And we need to know what is the purpose of this substation. A substation may include transformers to change the voltage levels between high transmission voltage to reduce the line losses that we require to step up the voltage, and lower distribution voltages, or at the interconnection of two different transmission voltages also we require the substation. A substation may be owned or operated by an electrical utility, or may be owned by a large industrial or commercial customers, like you can take the railways and BHELs, etc. Let us concentrate. So, what are the different type of the substations based on their functions? Let us see. Dear students, you can observe this is a one line diagram of substation. For example, you can take this is a one practical substation diagram, line diagram. Here you can observe what are the different bus bars. You can see this is a yellow color, is a one bus bar, that is a 220 kV voltage level you can see here, and 220 kV to step down to 132 kV voltage with help of two PTRs, PTR 1, PTR 2. Once again, so from 132 kV to 33 kV voltage further step down with help of another PTRs. You can see here. The voltage which is coming from the generating stations, let us assume 220 kV to 33 kV, how it is step down. During this process, what are the other auxiliaries is required? What are the different accessories and components present in substations? We are going to learn in clearly. Okay, so we will learn later. First of all, we will see what are the different types of substations. The substations are classified based on the different purposes and applications. That may be step-up substations, primary substations, secondary substations, distribution substations, industrial substations and mobile substations. These are the based on the purpose. At the same time, in electrical point of view, the substations are also classified based on the location, whether the substation may be outdoor substations or indoor substations, or sometimes so underground substations also present in real situations. Let us see these substations one by one with just one figure. So, because you are going to learn these all substations in power system subject, but in drawing point of view, at a glance, what is the substation, how it is a physical presentation you can see in figure. Okay, so let us see. Now, these are the substation classifications, and based on the location, the outdoor substations and indoor substations and underground substations. Now, we can see the primary substations sometimes. So, these all substations EHV, so EHT substations all are controlled with the help of the grid system. So, power grid is our government utility. It is controlling from 4 sides of the India. There is a power grid places, from that it is controlling and is taking the power from remote generating stations and distributing to the all states. Okay, you can see this one of the figure, the power grid substation. This is the main power grid substation. You can observe it consists of so many equipments. Let us see that also. Now, you can see the distribution substation where it distributes the power to the consumers nearby areas in the low voltages, whether 33 kV voltage or 11 kV voltages, or sometimes is a 400 volts to the domestic purpose. Now, you can see the mobile substations also. You can observe this is the one of the mobile substation present in a vehicle. It has all accessories. If any substation fails, so at that condition it may be used for the temporary purpose till restoration of the other substation, other equipment. Now, we can see the based on the location. So, you can see the outdoor substation here. It is placed far away from the populated area. So, it is exposed to the atmospheric conditions. Now, you can see the indoor substations. So, where place is not available, so they will use the indoor substations. All equipment or transformers and the accessories placed inside the roof. So, latest we are using the GIS, gas insulated substations, which takes a very less space for the same voltage, same purposes, but it is costly. Sometimes not only outdoor and indoor, sometimes we can use these substations. We can place these accessories the underground also. You can say that is the underground substations. You might observe in outside. You can see this one. So there is a here the poles, houses, below houses there is a, you can see the underground distribution substation, and there is a cables are provided here, quantity cables. So this is generally, you can observe this type of the underground are some industries and some private sectors they will use. So these are the based on the purposes and location. We have seen this classification of substations. Now let us concentrate on our topic, single line diagram of substations. How the power comes to our substation, and before going to the transformer primary site, what are the protective equipments, what are the measuring equipments required. At the same time, secondary side also, what are the different protective and measuring equipments is required. Let us see these are, so what are the main equipments. So detail in how these equipments work, what are the different types, we are going to learn in power system theory part. Dear students, at a glance you can just you listen, what is the purpose of this, what is this one, what is the purpose just now here as a drawing point of view. Okay, let us once again see the one practical, that's a well tour, one feeder substation we will see. Now you can see here, dear students, now for example, what are the incoming feeders is coming here. So from this place incoming, so from well tour, that is the location, from it is coming the 220 kV input line here, and another location also it is coming nearby that place, another feeder, and here you can see the Brahman cut core, that is another feeder, other place it is also incoming 220 kV feeder, and one feeder you can observe here, this feeder is an outgoing feeder, it is similarly is connected to the nearby places. Now that means here 1, this is 2, this is 3 feeders are incoming feeders, and 1 220 kV feeder is a outgoing feeders, you can see this one. Now before coming to the, this is the blue one, is the, this is the yellow one is the bus bar system. The bus, how much voltage we can check with the help of the bus potential transformer PT. Now before coming to this one, you can see some of the accessories present here. What are those? They may be lightning arresters, they may be isolators, they may be current transformers, they may be circuit breakers. And before that one, CVT, wave traps. So these are present in the high voltage systems. After that, it is connected to the bus bar, and after bus bar you can check here once again the protective equipments, and both side, this primary side, this is the primary side and the secondary side, and once again step down to the 220 kV to 132 kV, and it is connected to the another bus. So here this is a one PTR, this is a second PTR, both are connected in parallel. Okay, here PTR 1 is a 100 MVA and PTR 2 is a 160 MVA capacity, both are connected in parallel. So what are the different conditions to satisfy to connect the parallel operation, already we have seen. Now to load sharing purpose, we have used 2 PTRs, power transformers, both sides. And after step down here, so we have seen here, so what are the, once again same thing here, so 132 kV voltage, we are going to check it with help of the another, the bus PT voltage, and here we can see these 2 feeders are coming here further to the PTR1, PTR2, which are capacity 50 MVA and another 50 MVA transformer, where from it step down 132 kV to 33 kV. And at the same time, some places, suppose railway system is required, directly require the another outgoing feeder to the traction system. And this is another outgoing feeder, this is another outgoing feeder, and this is another outgoing feeders. So these feeders are directly goes to the nearby areas. In substation, two feeders we are taken for conversion purpose, step down purpose, you can see here. So dear students, so both before coming to the primary and after going from the secondary, so same arrangements, isolators, CTPT, and there is a CB, next is another isolator. So both are connected in, you can see here, further is connected to the same bus. So here in substations, so in addition to this one, so we are going to provide in 33 kV side capacitor bank 1 and 2 and 3 and 4. So because what will have 33 kV, so if the input voltage changes plus or minus, we know that 10% changes, then what will happen? We are going to switch on the capacitor banks to meet the load to generate the reactive power. So that's why, so 5 generally, so 5 MVA or 15 MVA are different capacitor banks provided here. At the same time, you can see one station transformer. So to feed the all accessories. So because here air circuit breakers, we require some compressor operation, 3-phase motor is required. In power transformers, we require the radiators, 3-phase supply is required. And that purpose, and station, switchyard, everything, we elimination purpose, and quarters and in area by this one, we require the one station transformers. And next capacitor bank 1, bank 2, bank 3, bank 4 is used to generate the reactive power generation based on the load demand. Okay, so these are the physically presence in every EHT substations. Okay, so dear students, you are going to draw these things. So for clarity purpose, I am going to see in details. Okay, let us, what is the lighting arresters, what is the CVT, how the isolators physically present in substation, you can see. Okay, let us see. So this is a one substation, real substation. It consists of, so what are the different accessories before going to the power transformer. Now let us see first one here, lightning arresters. So that will receive the incoming feeder power first of all. Lightning arresters are different types. Whenever the surges comes due to the lightning, so simply before going to the our costly equipment, that is the transformer, it divert to the ground. You know that lightning arrestor is consist of a non-linear resistive elements. That means under normal frequency, normal voltage, it acts as a good insulator. Whenever the surge comes at high voltage and high frequency, it acts as a good conductor. Such way that we are going to divert the surge. It may be occurred at any time. That's why it is the main protection. After that, you can see CVT, so capacitor voltage transformer. So this can be used as a potential transformer. It will measure the voltage. At the same time, it can be used for the carrier communication purpose also. So here you can see a wave trap also. Some wave traps also provided. It can be used the carrier communication purpose. That means we can station to station communication is possible through the this more higher frequencies greater than the 50 Hz. So this more than carrier frequencies, maybe 100, so maybe more than the 50 Hz, so doesn't enter into our transformer windings. To avoid that one, we are going to use a wave trap and CVT. So this both combination, so it will use to communicate nearby substations, to communicate, so what is the load demand, whether we are going to shut down load or operate the breakers or something, we can communicate easily instead of using the telecommunication lines. Okay. Now after that, you can see the another isolator. So isolator, you know that, so this isolator isolate the energy power. Whenever there is no current flowing through the line, we can operate these isolators. The physical isolation purpose, we are going to use it. So we cannot operate this isolator under load conditions, as already you know. So what is the purpose of isolators? Okay. After that, so we are going to measure what is the current loading on a line I required. In lower cases, I can use a ammeter. I can use a clamp meter to measure what is the current, but it is a high voltage and hundreds of amperes. I cannot measure directly in this case. That purpose, I am going to use some instrument transformers. What are the instrument transformers? CTs and PT. CT can be used as a current transformer and PT can be used as a potential transformer to measure the voltage, to measure the current. Now we can see the another important equipment is a current transformer, CT. The CT, each phase connected. So we are going to measure each phase current capacity in the line. At the same time, CT, the output terminals may be connected to the measuring purpose, protection purpose. This is very essential for the protective equipments and measuring purpose. So you can see that each phase having here this is one phase, this is one phase, and this is another phase, this is another phase. So three phase having the three CTs. At the same time, isolators also three. So R phase, Y phase, B phase. The isolators consist here. You can see the isolator movement also, whether the single break or double break. Okay. Now coming to the another important equipment that is known as here, you can see that is a very important, that is the circuit breaker. What is the purpose of circuit breaker? So here, under abnormal conditions, I want to open, I want to shut down my substations. Then under normal running condition, I cannot open this line. So that safety purpose, I am going to use a circuit breaker. It breaks the line without affecting. So that purpose, we are going to use the different type of circuit breakers in substations, EHD substations. We are going to use the air brake circuit breakers, that is the air pressure, air blast circuit breakers, SF circuit breakers, and nowadays we are using the sulfur hexafluoride circuit breakers is the very common. Olden days we are using the oil circuit breaker also, and in 33 kV, below 33 kV we can use the vacuum circuit breakers. Okay. Now SF circuit breakers are generally commonly used in our EHD substations. Dear students, you can see here, so this is the one line. So another line, you can see this is another line, two feeders. This is the one feeder and this is the another feeder. So these are the before coming to the bus bar, common bus bar. You can observe, dear students, so this is a CB, this is a CT, this is isolator, and CVT for this one lighting arrestor. This is one line coming from the, for example, you can take this is Ramagundam, and another line similarly this all arrangements may be from the, for example, you can say Kottagodam. This is the one line. So this is one line, this is a one line, both are connected to the common one bus bar. Before going to the bus bar, this all presents here. Okay. So you can see the size of our equipments also in EHD substations. Okay. So now I want to know that how these circuit breakers and isolators operate. And how we are going to operate this one, how the current will flows. You can see in a one animation, small animation for easy understanding purpose. Okay, let us see. Now here you can observe it. Let us assume this is the incoming supply from generating station. This is the power my house, for example this house or my substation. How the power is coming here? As you know, the circuit current will flows always with only closed circuit. Here main operation purpose we are going to depend on the circuit breaker. So in circuit breaker, so single circuit breaker may not be operate. It always along with the is sister. As already we discussed in previous examples, CT is sister and CB is a brother. Brother and sister always operates any operation. So brother is a CB, is a mechanically very strong, but he cannot take the decision once when to operate, whether it is open or close. So this signal comes from his sister only. The sister is a mechanically very weak, but is a mentally very strong. She can observe electrical characteristics in our line. Before fault, what are our electrical characteristics? Dear students, what are the electrical characteristics? I want to know. Will you tell it? Yes. The electrical characteristics, for example, current, voltage, frequency. Next, active power, reactive power, phase angle. All these are some characteristics of our electrical system. Just like, so what are whether this one person is active or patient, we can measure by some BP, by temperature, by testing some tests. Similarly, here also we are going to, before any fault in the system, what are the current, what is the voltage, what is the frequency, and what is the active power, what is the reactive power, what is the phase angle, etc., etc. we are going to analyze. These are placed in plus or minus in tolerance value. If the system fallen on the ground, some fault occurred in the system, at that condition, so 1 or 2 or maybe violates its tolerance values. The current may increased, voltage may be decreased, frequency may be changes, so phase angle may changes. That can be identified only by her sister here CT and with the help of the PT. So instrument transformers will observe, they are the detectives, observe in the system what is the characteristics under normal condition, what are the characteristics under abnormal conditions. If difference is more, you will give the signal to the relay system. The relay system will operate our breaker, whether it should be open or it may be closed condition. So this can operated under any condition, under abnormal condition, under load condition, such a way that we designed with help of some arc quenching devices, SF circuit breakers, oil circuit breakers, vacuum circuit breakers, and air blast circuit breakers. Different medias we are used. Okay, so this is a circuit breaker. So after that, it is coming to the common bus bar, and after once again isolator, same brother and sister. Now here is a lightning arrest is provided, that is just like a bodyguard to the minister. That's here who is the minister? Our transformer, costly equipment. This is in lakhs of rupees. We are going to protect it. So lightning arresters provided either side of the primary side and secondary side. Now dear students, I want to require current this side. Here I want the current. Okay, so this is my load. I connected the bulb. So here is the incoming supply. So how the current will flows, here you can see. So incoming from, so whether it may be 33, you can take the 33 kV substation. So here, so how the line will is coming, or 130 kV or 220 kV, any EHT substations. You can see here the operation. Now you can see here isolator is closed. Okay, isolator is closed before circuit breaker is open condition only. Then the current is coming from the incoming line, but circuit is open, current may not be coming. You can see here, so breaker is opened. Now I want to close manually, I want to close the circuit breaker. Then I close the circuit breaker. Then the current is passing through the isolator bus bars and coming to the next circuit breakers. Okay, so up to circuit breakers, if you close the circuit breaker, so it is going to this current. Okay, such a way that current will flows. If circuit breaker is open, if isolator is open, the current may not flows. Please remember this, dear students. Okay, so what is the lightning arresters? Already we have seen here. The lightning arresters are generally, okay, these lightning arresters are used whatever the, for example, if take the lightning discharges on the line at anywhere, we don't know, so where it is occurred, then traveling waves, the high voltage high when current comes, so before going to this side, so it will divert to the ground here. Okay, so that means, so under lightning arresters, if there is no lightning, okay, there is no lightning, then what will happen? So under frequency and normal voltage, non-frequency, so our lightning arresters act as a insulator. That means it acts as a open circuit to the ground. Okay, you can see, dear students. Now what will happen? Under normal frequency and normal voltage, our lightning arrestor act as a open circuit, just like so, open circuit insulator. Okay, now if lightning arresters or if any lightning discharge on the line, our frequency increases, our voltage also increased. At that condition, our lightning arresters simply close the line. So just like the closed line, it acts as a good conductor. Then, so whatever the current is coming here, it will directly flows to the ground. So instead of flowing in this direction. Hence, so here this side we require the very costly equipment. So we don't want to come this unwanted lightning towards our costly equipment. It is a diverted to the ground. So it has to discharge to the ground. That purpose I am going to use the lightning arresters. Generally, thyroid type lightning arresters, valve type lightning arresters, different companies has different designs. Okay, we are going to learn in power system 2. Okay, now after that what will happen? Here the CT. What is the CT? So here CT is nothing but just like it is connected here, and CT is connected to the one, for example, a meter, 1 meter. So here what is the current is coming here? So this it acts as a primary. This is a primary, and it acts as a secondary. So whatever the current coming in the primary is a CT ratio generally. So 100:1 amperes. That means whenever the 100 amperes flows in primary, here 1 ampere flows in the secondary. The 1 ampere is connected to the reading purpose, for connected to the meters, and another 1 ampere connected to the protection purpose. That means 100 amperes, 1 ampere and 1 ampere under normal condition. If the line fallen on the ground, fault occurred here, then what happened? So instead of 100 amperes, the current may be increased to the 1000 amperes. Fault current may be very severe, high. At that condition, so what will happen? The secondary current, so 100 is to 1 is to 1, then instead of here 10 times increases. So here 10 amps flows in the secondary. So once the secondary 10 amps flows, then automatically it will gives the ammeter a reading more fault current. At the same time, this another 10 amperes will goes to the relay system. The relay system will gives the signal to our circuit breaker. The circuit breaker will open because it will on the relay will gives something happen in the system. Just you open the circuit, isolate the circuit. Simply circuit breaker will operate. So the circuit breaker only operate with signal from the relays. The relays will work based on our PT instrument transformers, PT as well as the CT. CT will measure the current and PT will measure the potential transformer, will measure the voltage. Okay, so these are the CT purpose. Now PT generally they will provide the PT here also. One more PT also provided here. So here the PT they will provide the one transformer to the ground. This is the PT. That means what is the voltage of this incoming voltage? We are going to measure this one. So that purpose, this one is connected to the PT to the measuring purpose voltmeter, and another is coming to the relay system protection purpose. So this relay and CT relay both will desire always observe the characteristics of line current and will gives the abnormal signals to the relays, and the relay will operate our circuit breaker. Okay, so this is a CT PT. Now coming to the circuit breaker. The circuit breaker what is consist under normally, so if you can see this one, the circuit breaker is under this open circuit condition. So once current is stopped here only, once I close the circuit breaker by relaying system, it will close. During this process, there may be a spark may be occurred, arc may be occurred. This arc is quenched with help of the SF6 gas, sulfur hexafluoride gas. Okay, so that's why there is no spark arc come out from the chamber. This is a circuit breaker. Suppose I want the signal is given to the circuit breaker, mechanism will operate. So it will forcefully open the system. Once it's opened, chopping suddenly takes place. So a heavy arc may be occurred. This can be also quenched with help of our inert gas. Okay, so this is mechanically very strong. This can be operated with help of the relay signal. Okay, the CT and CB we know, and this is a bus bar. Next, what is the bus bar? The bus bar is connected to the another system. Suppose here is connected to the, suppose here I am going to connect in parallel connection. So another this one CT, CB and connected to the another transformer. Okay, parallel purpose I am going to use the bus bars. Whether it is going to the single feeder, whether I am going to connect the another feeder also. So one from the one place, another is coming to the different place, or sometimes from the bus bars itself it is going to the outside, so outgoing feeders to the different places. Okay, so here before going that one I am going to use the same my arrangements. These are this all arrangements, isolators, CT, CB, everything will present in the system. Okay, dear students, it is very easy. Every substations, every feeder, every line compulsory it consists of isolators, CTs and CBs. At end of the substation always lightning arresters presents. Okay, the simple circuit, dear students, no need to worry. So let us see what are the components present in substation. You can see these are the components generally. So mainly the lightning arresters you can see here, So what is the lightning arresters? It is placed at the starting of the substation, and you can see the isolators, different of the isolators, single break isolators and double break isolators, just as a post insulators supporting purpose. Sometimes some places we are going to use GIS, gas insulated substation also. So everything is present inside all. Okay. Now if you are seeing them inside the PTR, we are going to use the core material, 3-phase windings. And in control panel, control room, we are going to use the panel board. It will control all things. Today we are using the SCADA system. And so you can see the PTR, power transformer in substation, is a essential where we are going to step up or step down purpose. And you can see the instrument transformers, CT and PTs. And you can see the isolators, you can see the single break and double break isolators. Sorry, here is the insulator now, here is the isolators. And we are going to use this is the circuit breakers. So 3 R phase, Y phase, B phase, each phase separately we require the circuit breakers. These are the essential equipments in any substations where we are going to change the voltage, whether you are going to increase or decrease. So to operate this all in a healthy manner, we require the DC system. So that is a DC charging battery is also required in every substations and station transformers. Okay, these are the essential, dear students. Now you can see them wave traps and how the substation is here is a entering, incoming, and here is a outgoing step down. So here, and if you are zooming the ear, so what are the how the lines is connected to the substations, you can see here. Now you can see here, it is the incoming lines from the tower. There is a tower's presence here. Okay, so this incoming line R phase, Y phase, B phase. And before coming to the, you can see the one lightning arresters, dear students. And you can see the wave trap here is placed one phase wave trap for the communication purpose, PLCC, power line, carrier communication purpose. And you can see the CVTs also provided here. The CVTs also provided here. The CVT and a lightning, the wave traps are generally used for the PLCC purpose, and voltage also it acts as a PT. After that, it is connected to the, here you can see these are the isolators, double break isolators, you can see here. And after that, it is coming to our main items, circuit breakers here. You can circuit breakers. So after that, there is a CT presence. So every feeder, so you can see this is a one feeder, and you can see the another feeder, you can see here, this is another feeder, here is another feeder. 3 feeders are, you can see here. Maybe 2 feeders may be incoming, 1 feeder may be outgoing. Okay, so you can see that this is a bus connected. How this bus is connected, you can see here, common bus. And substation area is filled with the gravel. Okay, so this is one practical example, dear students. And you want to see the, so may there be more R phase, Y phase, B phase, one line, another line, another line. So for a big substations, you may observe some more number of lines also, portions. You can see this is the one substation here. So you can observe these are the, so you can, from this one you can observe this is the isolator. You can see this is a, what happened, this is isolators, you can see this is isolators, and this is a CTs, R phase, Y phase, B phase, and here is our breakers. Okay, now you can see the wave trap here. So coming power this direction. Okay, now it is connected to the common bus. You can see this is a one bus, this is another bus, common bus is connected. From the common bus, it is connected to the our another system. So dear students, so how the input is coming here, it is connected to the wave trap and CVT. Next it is connected to the once again isolators. After that it is connected to the circuit breakers. After that it is connected to the our CTs, and it is once again it is connected to the our isolators, and from isolators is connected to the either side of the CT, PT, we are going to connect the isolators. So physical protection purpose. Okay. So if any problem occurred in CT repair purpose, we are going to isolate the any equipment with help of the isolators. So isolators we can physically we can see whether circuit is open or, but whereas in circuit breakers we cannot open that one. So that is the problem. When the circuit breaker is closed off, if malfunction occurred, what will happen? There is a dangerous accidents. To avoid that one, we are going to use a isolators in each section. Physically we can see whenever the isolator is operated, opened, it is automatically connected to the earth switch. So whatever the induction charging current, that is diverted to the ground. So the operator can easily repair the any equipment. That purpose we are going to use the isolators. Next, so this is a bus bars. So we can see this system in our single line diagram. Okay. So dear students, you can see here. Now this is a one incoming line. From incoming line it is connected to the lightning arresters. So as we discussed, incoming first of all it will receive lightning arresters. Next we connected the isolators. We connected the brothers CT and CB, and after that, so if it required, I can connect the one isolator also. Then I connected the one bus, and bus here I connected the one PT. So it is a PT will measure the what is the voltage of this bus, and again bus isolator here also we connected, and we connected the another line, another feeders. So here once again isolators, same brother and sister, and isolator and lightning arresters. So bodyguard to the transformer primary and bodyguard to the secondary, and next same thing isolators and brother and sister and isolators and bus bar. This is a common, dear students. So only this one. And here what is the voltage step down I am going to use with help of my another PT connected to the bus. Suppose here load is more, require the load is more, then I can close the this isolator, then I connect it to the another step down purpose, I can use a PTR2. Then PTR2 will operate, so it will give the some more step down to the voltage here. It is connected to the common bus. Okay, you can see the one animation for easily understanding purpose, dear students. Now you can see first the current is coming here up to the first CB. So once the CB is here, isolator is closed, incoming feeder, and there is no lightning, that's why lightning arrestor act as a insulator. Now isolator is closed and CT is observing, and first CB it is coming. Once I close the CB signal manually, then it is going to the bus bar. After that the isolators, let us assume isolator is closed, and coming to the second stage where the CT and CB presents. Now CB is not closed here. Once again I want to close it, then I can close the this also. Now after closing the CB, the current is entering into the primary of our PTR1 power transformer primary side. There is a voltage, for example, you take the 220 kV voltage. Now 220 kV is stepped down to the 130 kV in secondary line. Now the secondary voltage is going to the another bus bar with help of the same arrangements. Now the CT CB I am going to close it. Now I will close it. Then it is going to the CBCT step down to this one. You can see the size of the stars also, that is the current. You can let us take the current step, the secondary current is a more now, the current is increased, then the CB is closed here. What will happen? It will goes to the my load. So let us take this domestic, or it may be traction system 130 kV direct will take. so load is available. Okay, so this is how this incoming line 220 kV and step down to the 130 kV and given to the so nearby 130 kV loads. If railway system is more trains are going on the line, more power is required. Now the PTR1 may not be meet the power demand. Then I am going to close the PTR2. Okay, then so I am going to close isolator, bus bar isolator. Then the power is going to the second PTR. Now CB, I will close the CB, then it is going to the primary side of the PTR2 and step down to that PTR2 and will give to the another circuit breaker and it is connected to the bus. Okay, so now you can see the power is going to that one and continually, so the power will flows and meet the, if required I can close the bus isolators such a way that the power is flowing from incoming to the outgoing, dear students. You can see the PTs are 2 PTs. Every bus there is a 1 PT is enough, but CTs are every phase we require R phase, Y phase, B phase, every line we require the CT or PTs we require the R phase, Y phase, B phase, just bus bar is enough. Okay, you can see this is the one idea purpose I am going to tell you. So dear students, your aim is to draw single line diagram. These are all theoretical part. So this is the only basic idea. Now your aim is to draw this simple single line diagram 220 kV by 130 kV substation with help of the dropter neatly. So what is your task? Let us see. This is what task. Can you draw it? Yes, simple. So now we have seen everything. You can see here what has happened. So here feeder 1 220 kV incoming line 1 is coming. So here before coming to the this one we have the isolator, we have the lightning arresters, we have the CB circuit breakers, we have the CT. Now we have the PT. So this is the voltage purpose, this is the current purpose, this is the current purpose, this is the braking purpose. So this is protection purpose, this is the isolation purpose. Everything is okay. Now, so instead of connecting the bus here, it is connected to the ear, common bus. Now here another isolators. You connect to the two buses are used here. So we can use at any time one bus. So 220 kV line 1 and 220 kV line 2. So if any problem occurred, suppose the breaker is not working, then I can convert it to this side. Protection purpose. Okay. So work is same, dear students. Now coming the another feeder, you can see the 220 kV line 2, it is coming. So it has also same arrangements, it is connected to the ear and this is the connected ear, this is connected here. This is a bus bar. Now our PTRs are ear presents. Okay. So now here I am going to connect it. So it is connected to where you are going to, so from ear bus it is coming here, it is coming here and same CTPT arrangement CBs and primary sides and CTPTs here you are going to connect and I am going to connect the one bus 132 kV bus, you can see. From 130 kV bus, so outgoing feeders step down. So before going that, so everything presents our CT, CB, lightning arrest, everything presents, you can see here. This is outgoing circuits 130 kV. And here the bus couplers also we are using. So whether there are two buses, so standby purpose, that is you have the two vehicles. So one vehicle is punctured, then you can use the another vehicle. That's purpose you can use the, because it is an emergency system. So always redundant. Okay, here I am going to use this one, it's 2 PTRs and here going to use this another outgoing feeders 130 kV here 3 feeders and 130 kV 3 feeders. Or sometimes we are going to use the 220 kV outgoing also. You can see here the 220 kV outgoing feeders. So it will take the power from different places, it will give to the nearby substations. Something problem occurred here, then what will happen? They will take the here this 220 kV substations. So two directions. Okay, that purpose there is the bidirectional relays in the protective systems. Okay, dear students, just you can see it and draw as it is, but you have to remember. So our isolators, circuit breakers, CTs and isolator setting. This setting always settings set, and PT for every bus bar. Okay, transformer either side we are going to provide the lightning arresters. So after secondary side we are going to change the voltage. So before going to the secondary, if you are connected to the line, that is going to the direct voltage outgoing lines. Okay, dear students, so your aim is to draw this one. Okay, so let us stop here. So dear students, what we have seen in this class, so we have seen that what is the substation, what is the different type of the substations based on the different factors, what are the different components present in substations, and what are the how they are connected in sequence order. And now we have seen how we are going to draw this line diagram. Okay, suppose if you want to draw manually, I can draw the incoming feeder first one, and I use the one isolator. Okay, now it is connected. After isolators we are going to connect the one lightning arresters LA. Next I am going to connect here one circuit breaker CB. Okay, this is arrangement CB. Now after that I am going to connect the CB has to work. That purpose we require some assistant. His sister is required. The sister is a CT. This is a CT. Okay, now it is connected to the bus bar, or you can connect to the here there is a two buses, you can see here, bus 1 and bus 2, redundant purpose, protection purpose, and two buses are connected with help of isolators. Okay, so sometimes we can use the breakers also. So we are going to connect, this is the common way. Okay, that means if I close this one, the whatever the current comes, and the closed they went at the current bus 1. Okay, now after this one, if another feeder, you can take the next another feeder. Similarly, same operation, same another. So another incoming feeder, for example, you can take it. Same lightning arresters, same CT, and is connected to the here. So this one. Okay, so this is the one bus. Suppose let us we are using the bus 1 only active. Now the power, whatever the 220 kV coming from NTPC line, so given to the power supply. At the same time from Kottagudem. Okay, so 220 kV line Kottagudem, that is also coming the line, it is connected to the bus bars. So from here incoming from NTPC Ramagundam and 220 kV from one line from Kottagudem. Both are connected to my substation, is the power is given to here. Here from the substation I am going to connect my system, where I am going to have the my transformer primary and transformer secondary, and the transformer primary side I am going to connect my, what is this one, lightning arresters, and before that I am going to use the isolator. Then I can use the brother and sister CTPT, then I can use the same isolator, then I connect to this line. Okay, so this is the arrangement, primary side. So whatever the power coming, 220 kV power, it is going to the isolator, CT and CB. Next isolator, lightning arresters, incoming 220 kV incoming. Now step down to the 132 kV line. Once again I am going to use the another lightning resistors. Maybe lightning maybe comes in either side, LV side, HV side. That's why I provided the bodyguard both sides. Next I am going to use the isolator. Next, brother and sister, CT and PT. Okay. Next, isolator. Now that feeder maybe goes directly to the load center, or you may connect to the common bus. Okay, the common bus. Now you can see the CT, CB, and so this is a one transformer. Suppose I want to connect the support, load is required more, further same arrangement I am going to use same thing here. So both are connected, common bus, here bus coupler I am going to use it, this one. From this one it is going to the different feeders. This is a 132 kV feeders. Same arrangement, isolators, circuit breakers and CB, and isolators is going to the outgoing feeders. So these are the all feeders. Okay. So sometimes I want to use outgoing feeders. So from this one I am going to connect isolator and CTCB and isolator, and from this one I am going to connect to the outgoing 220 kV feeder. Okay. So both are incoming, it is going to this, for example, Hyderabad, nearby Hyderabad, 220 kV line is going. So here the feeder, which is the 132 kV feeder, is going to the outsides. Okay. So dear students, so very easy, this is the operation. Please, by seeing the figure you draw it, but you remember sequential order of this all accessories. Okay. So please practice it. Thank you for listening my class, dear students.